All right, good afternoon, grade eights. I hope that you guys are all having a productive week so far, and that Tuesday has treated you well. Guys, we're back for the 20th lesson of the year, which is quite exciting. It's definitely an achievement of note. Um, 20 lessons is quite a lot. If you think about it, it means that you guys have got access to 20 hours worth of videos and lessons to go back and rewatch if you want to revise or just get extra information on specific topics. Um, and as great as it is to already be 20 lessons into the year, guys, and that does mark the halfway point through the year because many of you will be writing exams now, we still have some more work to do. We've still got quite a few lessons left to reach the end of the year, but we're going to keep up with the consistency, keep up with the momentum, and hopefully it benefits you guys in some or other way. So, guys, we're going to get started with our lesson quite soon. I just want to give everybody an opportunity to join us. But in the meanwhile, grade eights, please make sure that you guys have got all of the stationery that you need for today's lesson, which will include pens, pencils, and a ruler, because we are going to be doing a little bit of drawing. And guys, once you are then set and ready to go, if you have any questions, you're more than welcome to quickly ask me while we wait for the others to join. But then we're going to get going with our lesson. All right. And I just wanted to point out, guys, today we're going to be talking about a lot of the requirements that we have for drawing graphs, which is going to be very important for all of the sections of school that deal with graphs, right? If you're taking, you won't be taking biology yet, but while you're still taking sciences of sorts, you will still be drawing graphs, okay? I hope that makes sense, guys. Okay, guys, I'm going to give everyone just 2 more minutes and then we're going to start with today's lesson. All right, thank you so much, grade eights. All right, grade eights, it's time for us to get going with today's work, guys. So I'm not going to make any of you that are already here wait any longer. I'm going to start by sharing my screen with you in a second, and we're going to get going. So just to give you guys a little bit of context, last week, grade eights, we started discussing the topic of data handling. And we broke the topic down by understanding the different subsections that exist, right? We spoke about data collection, data organization, data representation, and then data analysis and interpretation. Those are the four sort of subsections that we find in the world of data handling. And one of the things that we really do have to understand when it comes to these sections of work is that we must be very competent when it comes to drawing our graphs. So that's what we're going to be focusing on today. To a certain extent, it's not the only thing that we're going to be talking about, but it definitely is going to form a definitive chunk of the lesson. Okay, so guys, in a few seconds time, you should see my screen pop up on your screen. And I'm going to be scribbling. So please let me know if for some reason you cannot see the different colored pens that I am scribbling in, which would include white, yellow, orange, green, and even a little bit of blue. If something happens during the lesson and you guys can no longer see what I'm writing, you need to please let me know so that I can then fix whatever the issue might be. Okay, but our heading for today is going to be understanding data representation. So you can go ahead and write that down as your heading. The date for today is the 3rd of June. And before we can understand data representation, right, the different ways that we can show information on graphs and diagrams, we need to know what the different kinds of data are. Right. So let's start with that. Right. So let's go ahead and understand the types of data first. That's the most important thing that we need to understand in today's lesson. So what are the different types of data that we get, grade 8s? The first kind of data that we get is what we call qualitative data. Qualitative data. Right? What is qualitative data? Well, qualitative data is a kind of information or data that we collect that is measured by the quality of something instead of a specific mathematical quantity, right? So, for example, when I talk about qualitative data, we can maybe talk about different colors that are included in the rainbow, right? We collect information about the different colors that we can find, and I don't tell you that we have 6 of this color or 12 of that color. Instead, I'm simply telling you that we have descriptions of data rather than values, right? So qualitative data is data measured by a quality, right? By a quality of something. Data measured by a quality of something rather than quantities. Rather than mathematical values, like numbers, right? So that tells us that the second kind of data is the one that we work with very frequently, which is what we call quantitative data. Quantitative data is information that is measured using specific values. Right? Quantitative data is numerical. Right? It is a numerical format of data. Using all 4 major number forms. So we talk about using percentages, whole numbers, decimals, and fractions. All of those are examples of quantitative data. So why does this matter, guys? Because the type of data that we have impacts the kinds of graphs and diagrams that we choose to use when we decide that we want to put this data on display and represent it in a visual format. Right? But we can be just a little bit more specific about all of this and dive into a little bit more detail. What do I mean by this? Well, now we know that we have qualitative and quantitative data, but weirdly enough, guys, quantitative data can be split up into its own two subsections, right? So under quantitative data, we have two kinds of numerical information that we collect. We have what is called discrete data, right? Discrete quantitative data. What is discrete quantitative data? A numerical, sorry guys, let me just rewrite that. It is a numerical measurement using only integers. Right? Using only integers. That cannot be subdivided into smaller parts. So what would an example of discrete data be? Well, it's simple things, guys, like for example, calculating or counting the number of people in each class, right? That's a form of data collection. Schools do it all the time to count the number of students that are going to appear in each class. We know that they can only be 5 or 12 or 23 students. It's not possible that we have 8.6 students, right? We cannot have, for example, a fractional value, right? I can't have 7 out of 10 students, 7/10 of a student. But the other kind of data that we work with is what we call continuous data. And the reason why we need to make a distinction between these two guys is because they inform our choice of data representation. Right? So for example, the number of customers who have bought different products. Maybe I can talk about the number of shopping malls in South Africa, right? That's going to be a definitive number that cannot be broken down into pieces. I can't say that I have 6.5 shopping malls available. It's either 6 or it's 7. But continuous data is slightly different, right? It's often considered to be the opposite of discrete data. So it is also a numerical, or it's just numerical values, right? Numerical values, not qualitative data. It's not descriptions, it's numbers. But it's numbers that have an unspecified number of measurements between two specific points. So numerical values that can be subdivided into smaller units to show continuity, right? To show progress or continuity. So what is an example of continuous data then? What is continuous data in this case, guys? Well, let's, for example, just take a quick example over here. And let's talk about the temperature outside. 0 degrees, 1 degrees, 2 degrees, but it can also go down to -1 and -2. This could be an example of discrete data, right? But the reason why it's not is because we can subdivide each of these sections into smaller pieces. So is it possible for it to be -1.8 degrees Celsius outside? Yes, it is. Think about your weight on a scale. You can be okay, that's unrealistic. 58,63 kilograms, right? That's halfway between 58.6 and 58.7, which is in between 59 and 58. So we can take these values and break them down smaller and smaller and smaller to get even more specific, right? We can introduce more decimal values, right? Think about the speed of something. You could be traveling at 63.845 kilometers per hour if we had a really accurate way of measuring your speed, which sits between 63 and 64 k's an hour, just as an example. So continuous data allows for us to make these subdivisions between two specific units. And the reason why this is so valuable, grade 8s, is because it gives us accuracy. Okay, in brackets, you can, or somewhere else on your page, just write a note about discrete data being specific but not very accurate. Continuous data, however, what we've just looked at now, allows us to be incredibly specific, right? It's the reason that, for example, if I look at a swimming race, and we see that this is the 10-second mark and the 11-second mark, I can have 3 different athletes all land between 10 and 11 seconds, right? Maybe the first athlete ran 10.3 seconds, right? We can then have 10.7 seconds and 10.8 seconds. This idea of continuous data, right, that allows us to break things down more and more to get more and more specific is really useful. And it's the reason why we can be so accurate when looking at things like temperatures, weights or masses, right, times, distances, and so on and so forth. Can you imagine trying to build some kind of science project, right? Let's say you were asked to build a bridge to show how different shapes can help us to bear heavier weights, right? Can you imagine I could only work with 1 centimeter and 2 centimeters, 3 centimeters, 4 centimeters, instead of being able to use 1.6 centimeters and 2.5 centimeters, right? The reason why buildings and stuff can be so efficient, effective, and accurate is because of our ability to break values down like this. Okay. I hope that makes sense, guys. So you need to be aware of these different categories of data because you may be tested on it. Okay. Please remember that discrete and continuous data are both forms of quantitative data, which means that they are numerical. They work with numbers, not descriptions or qualities. Okay. So when we decide that we have a specific kind of data, how do we go about choosing the different types of, or choosing which of the different types of graphs to work with? Well, let's go ahead and write down the types of representation. What are the different ways that we can represent our data? I'll give you guys an opportunity to copy now in a second. I just want to quickly write this subheading down. Okay, you guys can quickly finish copying and then we're going to move on. If you have any questions, grade 8s, now would be the time to ask. Right, let's go ahead and take a look at the types of representation that we might use when um, plotting information in a visual format. So, what are the different types of graphs that we can use, grade 8s? You guys do need to be familiar with all of these graphs and be able to draw them. Unfortunately, I cannot go through every graph in this lesson, but what I am going to do is write down a list of different ways that we can represent our information and then give you basic tips that you need to follow when drawing your own graphs. So the first kind is a bar graph, but it's important to remember that there are many different kinds of bar graphs. We have a normal bar graph, a stacked bar graph, a compound bar graph, and even a horizontal bar graph. You guys need to go and check out the differences between these graphs, right? But a normal bar graph would quite literally just have its individual bars like so, nothing too complicated. A stacked bar graph means that we would have little pieces stacked together to create our bars, right? And these different stacks would represent different values or concepts. And finally, a compound bar graph would mean having bars that are paired with one another, right? So for example, we could have a bar graph that looks something like this, for example. Right? This would be an example of a compound bar graph where we would use color to our advantage or some kind of symbols to create a key. So you must be familiar with the 4 different kinds of bar graphs, guys. A horizontal bar graph is just a normal bar graph with the bars moving horizontally as opposed to vertically. Right, it's very helpful to show progress over time. Next, what other kinds of graphs do we have, grade 8s? You guys should know about histograms. Right, histograms are very, very similar to our bar graphs, but histograms have no spaces, right? You can write that down as a note if you'd like to, up to you. There are no spaces between the bars. So all of the bars are touching like so. Right. And there's a specific reason why we sometimes have graphs with gaps and graphs with no gaps. Next, after histograms, we have what is called line graphs. Right, these are no surprise. And again, guys, there are one or two different line graphs that we can talk about. Right, we have a normal line graph. We also have a compound line graph. Right, there are a few of them. So let's quickly write one or two notes about that. Sorry, guys, just give me a second. Right, so we have a normal simple line graph. We have a compound line graph, which means that we have multiple lines on the same graph. Right, we can have more than one line, absolutely. And there are a few others, guys, but these are not the kinds of graphs that you guys need to be aware of. Okay, so I'm actually just going to leave the list over there. Now, one of the charts that are very important for you guys to understand is pie charts, right? This isn't a specific kind of graph, but it absolutely is a format in which we can show our information. So pie charts are very important because you should understand how to draw them and calculate the different sizes of the sectors, right? So you should be able to draw a pie graph or a pie chart from scratch, calculating the size of each of these sectors on your own. If you cannot do that, guys, I would suggest you go and practice drawing your pie charts, because it's very possible that it could be asked for you to draw one in a test or an exam setting. Okay, please make sure that you know how to complete all of the calculations. Then lastly, guys, I'm not going to go through too many more, but we have a scatter plot. A scatter plot, which is a type of graph that we draw that has each data point represented as a dot. But because there are often so many of them, we don't connect them with one solid line. Instead, we have what is called a line of best fit, right? So we would start at the beginning and try and run our line through as many points as we can. Right? That is an example of a scatter plot. So it's great that we get to know the different types of graphs that we use, but it would be a little bit more helpful if we knew what type of data would be best represented on each of these types of graphs. So let's start at the very beginning with our bar graphs. Bar graphs are very good at representing discrete data, right? In other words, when we count things and there's 6 and then 5 and then 2 and then 9, simple numbers, simple integers, whole numbers, right? Those numbers, which we call discrete data, are very good in a bar graph. In a histogram, we would be more likely to use continuous data. It's not to say that you can't use discrete data, but when we draw a histogram, guys, remember, a histogram is essentially like a bar graph, except our bars are all touching. And the reason that we do this is to show the idea of continuity, grades 8s, right? When all the bars are touching, it's showing how things are progressing over time. And it is very helpful for continuous data. So, for example, if we were talking about the speed of the wind over time, over the course of 7 days, 1, 2, 3, 4, 5, 6, 7, let's just say 8 days, right? The speed of our wind can change quite drastically over time. And so when we look at a histogram, we can see that the speed of our wind first started off quite high and then dropped, increased a little bit, and then fell very quickly before gradually rising again, right? So histograms are more for a continuous data than a discrete data, but it is a little bit of a tricky one because sometimes we can use both types of data on this graph. Okay, line graphs, guys. Line graphs are best for continuous data. We do not use discrete data on a line graph, right? So when I create a line graph and I plot all of these different points, the reason why I connect the points is to show what happens between 2 points in time. So for example, over here, this is maybe day 1 and this is day 2. Although I can see from day 1 to day 2 I've gone up, when I draw a line, it tells me how quickly I've gone up, right? Is my line super steep between 2 points, or is it super flat, showing that the change was very gradual and slow? Right? So that shows us continuity, how things change over time. That's why line graphs are best for continuous data, and that's why we use it a lot in science, for example. But in business, you guys will tend to use a lot of bar graphs, for example. Right. Pie charts, guys. What would we use pie charts for? 99% of the time, we are using pie charts for discrete data because it shows a definitive amount of something, and it doesn't have to be with a ridiculous amount of accuracy. Okay, and a circle like this doesn't show how things have progressed over time, but rather tell us about the distribution of something over a few different areas. And finally, guys, scatter plots are also great for discrete data. Okay, this is for more random data collection than it is for measuring something over time. So although these are not 100% steadfast rules, I think it is helpful to at least have a rough understanding of what graph you should be using depending on the type of information that you have in front of you. So I'm going to give you guys an opportunity to copy. If you guys have any questions about these different kinds of graphs or data types, please make sure you ask me. I'll give you guys 2 minutes to quickly copy. Okay. So guys, number 3, let's just write down a few graphing techniques that I think you guys should know. Some things that you need to remember when you decide to draw your graphs. Generally speaking, at high school level, grade 8s, your graphs are going to be anywhere between 5 and 9 marks a piece. So in order to get those 5 to 9 marks, we need to understand what exactly is expected of us when it comes to drawing our graphs, right? Although dealing with data is not the only, or is a huge part of drawing graphs, it's not the only thing that you're actually going to be awarded marks for. So, what do we need to remember when we're drawing a graph, guys? There's a few things. First things first, you always need to include a graph heading, right? And it must mention both variables, the dependent and independent variable. Right, next, I need to have axes headings. Right? You must include a unit symbol when you do this. I'll show you an example of this in a second. What else should we know when we are graphing any kind of data? We need to have equal intervals. On both axes. To avoid skewing and distortion. Next, what else should we be careful of doing? Plotting values carefully, or rather accurately and neatly. So for example, guys, if I am drawing a line graph, I need to make sure that my dots, oh, sorry about that, guys. I need to make sure that my dots are quite clear. They shouldn't be too small, but they also shouldn't be obsessively big. Okay, we should have just very visible dots. And for example, when drawing a line graph, we need to make sure that our lines are connected with a ruler, not by hand. Okay, when we draw bars for a bar graph, we draw with rulers. When we draw a pie chart, we need to make a very accurate circle so that when we measure the angles in that circle for the different sectors, we are working accurately. Okay, so we've got a graph heading, axis heading, equal intervals, accurate data plotting, right? And sometimes you will need to include a key, occasionally include a key or legend if necessary. Right, so what does all of this look like in practice, guys? If we go ahead and quickly draw a graph, we're going to do the following. 90% of the time, guys, you are only going to have a graph that's drawn in the first quadrant. You're not going to have to worry about the fourth quadrant or the second quadrant. So just the top right-hand corner, in other words. We don't need to make other sections for this graph, right? We are only working in the top right over here. So when we decide to draw this graph, I don't know what our information is specifically about, but we are going to make sure that we begin with a graph title, okay? Our graph title sits above the graph, and we need to have headings for both of our axes. Let's say I'm measuring time on this axis, for example, right? We would say this is the axis representing time, and we measure time in seconds, right? Or maybe days, but let's say seconds. Let's say I'm dropping something from a building, so I want to pay attention to the height of an object as it falls over time. The height of something would be measured in meters, maybe, right? Meters above the ground. So we include both the name of the information, but also the unit of measurement. I told you guys that when we are looking at the individual axes, we don't have one marking here, then a massive gap, then a tiny gap, then another gap like that, right? We do not deal with spaces that are this uneven. Why? Because when we decide to draw our graph, it's going to completely skew our data, and we do not need that happening. Right? So instead, whenever we do graphs, whenever we draw them, we take out a ruler and we make sure to mark very clearly using equal measurements, right? I don't have a ruler in front of me, guys, but you will try and be as accurate as possible, fitting your graph to at least 3/4 of the page. Right? You fit your graph to 3/4 of the page size, whether it's normal paper or graphing paper. You don't want to have an entire page of information like this that you can draw your graph on, and you just end up drawing a little teeny graph over here, right? Guys, if you have the space to draw a graph out and expand it visually, use that to your advantage. Okay. So we are going to have equal intervals. Very important. Then, guys, as far as your data plotting is concerned, we know that we need to plot our data very neatly. Right? Whatever the case is, you're going to plot it neatly in pencil. Okay? And then you may, draw onto the graph however is fit for the time. So whether that's drawing dots for line graphs or drawing bars for bar graphs and histograms, that's up to you. And one last thing, guys, on our axes over here, I can count 1, 2, 3, 4, and so on, like this, where we count up equally, right? But I may not decide that I'm going to start at 1, then 23, 60, 2000, and make all kinds of weird jumps. Okay, if I'm going to count in a specific number, continue counting in that. So if you don't want to do ones, maybe you count in fours. But the numerical difference between consecutive interval markings should be as equal as possible. Okay. So pick a scaling factor to count in and stick to it. Okay. So guys, I haven't seen any questions yet, but these are some of the rules that we really want to apply when we are paying attention to drawing our graphs accurately in order to get the most marks that we can, right? So again, if I were to mark this as a teacher, guys, how would I do such? Well, you're going to get 1 mark for your graph title, 1 full mark, so essentially half a mark and a half a mark on each of the axes labels. 1 for the correct measurement being on the correct axis, and then using the correct unit as well. So that's 3 marks so far. 4 and 5 for counting in the correct values on each axis, and maybe, for example, 2 marks, which is usually the case, for plotting your data accurately. And if you've drawn a line graph, for example, 1 of those marks will be awarded for connecting your dots with straight lines. Okay, so for example, in this case, guys, this is a graph that would award you 7 marks if you made sure to follow each of those steps. You have to complete each one correctly to get the steps, but that's exactly why it's worth practicing, because even if we have a test out of 50 marks, right, those 7 marks for that graph counts 14% of my test. 17% of your test. 14% of your test just for a graph if it's 7 out of 50, for example. Okay, so I'm just trying to show you guys that there's a lot of value in understanding where marks and how marks are awarded when it comes to drawing your graphs. So this is some of the information that you need to stick to when drawing bar graphs, histograms, line graphs, scatter plots, right? If I were to draw a pie chart, for example, although I wouldn't necessarily have bars, I would still go and use color coding, right? Which I would need a key for, which would give me a mark. But I would still get marks for correctly sizing each of the sectors. I would still need a pie chart heading overhead, right? Which would be worth more marks. So there are certain things that are going to remain consistent even when we draw other kinds of graphs. All right, guys, I hope that makes sense. But this is what you should be aiming for when we are drawing graphs for different classes, most definitely in maths, but also in other subjects. All right, so grade 8, that really is the end of today's lesson, guys. We have finished about 8 minutes early, but I haven't seen any questions from anybody, so I am curious as to whether or not we have any questions. So if there's anything you guys would like to know before we wrap up for today, you're more than welcome to ask your questions in the comment box for me. But I hope that what I've discussed in today's lesson makes sense. Remember, all of this has got to do with data representation. So when we start looking at data in tests and exams, we have to be able to identify the kind of data that we are dealing with so that we can then select the correct style to show it in. But then we must also be comfortable and competent when it comes to drawing each of those different styles, whether it's a line style, a bar style, right? All of these different kinds of graphs. You need to know the unique characteristics and requirements for each of these graphs. And this is something you guys should have discussed quite extensively in class. But I hope that today has maybe given you a little bit more information or maybe helped you to understand some small detail a little bit better. But given that I haven't seen any questions, guys, I am going to assume that everyone is happy. And guys, we are therefore going to be done with today's class. All right. Grade 8, please remember that we have got recordings of the grade 8 sessions that have happened throughout the year stored on the iRainbow exclusive community Facebook page and also on the iRainbow Education WhatsApp channel. So I hope that you guys will go and use these resources to your advantage. I understand that maybe the topics we cover each week are not always going to perfectly align with the work that you were doing in class, but I would hope that you guys still use this to your advantage. Okay, now because this is not a specific section on iRainbow, right, drawing graphs, we don't have a quiz for today. But guys, once we cover a little bit more work next week, we will go and tackle a new quiz on iRainbow like we did last week. So in the meanwhile, guys, I hope that you will still go and use iRainbow for whatever sections you are busy with in class and for any of the sections that you feel you need a little bit more practice with. All right. So grade 8s, guys, that is going to be it for today. I wish you guys the best of luck for the week ahead, and I hope that any tests or exams that you have coming up go smoothly. But guys, our next lesson will be again next week. Dates and times will be sent to you guys on Monday morning just to confirm them. So please keep an eye out for a message on Monday morning so that you can time manage appropriately in order to try and attend the next lesson. All right. Thank you so much, grade 8s. Have a fantastic evening, guys, and I'll speak to you all again next week.